Hello everyone, this is Fixed Maintenance College. I'm Anthony. From now on, we will have iPhone 8 repair course. Today, we will begin Lesson 1, iPhone 8 Power On Principle. Before we start our class, we need to understand the power on process first. Number 1, battery provide power to main power of PCB. Number 2, main power start to work when press power on button. And main power provide 28 circuits of low voltage power to mobile phone. Number 3, main power provides 16 circuits of low voltage power and 1 circuit of reset signal to CPU. Number 4, CPU start to work and check itself. Number 5, CPU verify load components by I2C. Number 6, CPU verify the logic EEPROM by I2C. Number 7, CPU verify the NAND. 8, the NAND start to work. And number 9, CPU extract data from NAND and make the phone on. As we know, if we want the phone on, it needs power. And the power is from battery. The battery is connected to J3200 and pin 1 output positive power PP BATT VCC. And the U3300 transform positive power of battery to PP VDD MAIN and output to PMU. Then U3100B positive transform PP VDD main to PP VDD boost and output to PMU. And the PMU works need PP VDD main and PP VDD boost. Let's check battery connector of PCB. Battery is connected to PCB. The positive power is from PCB. Let's check it out. The positive power of battery is output from here to this charging component. This component is called U3300. It transforms PP BATT VCC to PP VDD main. And then output to PMU. That is powered. After U2700 receive power, PMU will stand by. And the power on bottom is integrated in bottom cable, and the cable connected J4300. And then let's check pin 13. Pin 13 is the power on bottom working signal and the PMU working signal. When mobile phone standby, J4300 pin 13 has 1.8 voltage power, and this moment shows this function is not activated. The Y3000 is clock crystal of 32.768 kHz. It provides clock signal to PMU. When the phone connected to the power, Y3000 starts to work. When you press the power on button, it means make pin 13 to GND. And the voltage of pin 13 is changed from 1.8 voltage to 0 voltage. When PMU cannot detect the 1.8 voltage of pin 13, that means PMU need to work. And this status will stay 3 to 5 seconds. Then PMU working. After receive power, PMU start to work. This is power bottom connector. When we connect the power bottom connector, if we want PMU to work, It needs 32.768 kHz clock crystal. After PMU work, it provides 28 low voltage power to PCB, 16 of which are sent to the CPU to provide necessary power for the CPU. When CPU receives power, it will stand by. And after the CPU receives power, the Y1000 24 MHz clock crystal will provide the clock signal to CPU. After that, the PMU sends reset signal to CPU, and CPU returns to original state. And next, CPU works after it receives 16 lines low voltage power of PMU, reset signal and 24 MHz clock signal of Y1000. And then CPU starts to work and check itself. In the meantime, CPU verifies load components by I2C and verifies the logic E point by I2C. Also, it will verify the NAND. And finally, CPU extracts data from NAND and make the power on. When PMU receives power, press the power button. PMU start working. If the 24 MHz clock crystal OK, PMU will output many lines of power to CPU. And CPU receive power, it will get the clock crystal. Then CPU start working. After CPU working, it will take the power on data from NAND. Now let's check 24 MHz clock crystal of CPU. This is the 24 MHz clock crystal of CPU. Okay, when we know the process, let's check no power on repair idea. The steps of no power on repair idea. First of all, you need to take out the PCB and connect to the power cable and power supply. Then check the current. If the current shows 0 mA, it means PMU is not working. Just check PMU power PP VDD main and PP VDD boost OK or not. If not, check and replace relevant components. And then check the starting signal of PCB power on bottom OK or not. If not, replace the cable and make jumper. Then check the Y3000 clock crystal of PMU OK or not. If not, replace the new one. When repairing the power error, we need to check the changes of current. Firstly, connect PCB to power supply. Then turn on the phone. Now it's on. Check the starting current. It is helpful for our repair. Number 2, if the current shows 0 to 50 mA, it means PMU is working, CPU not working. Check 1.8 voltage of CPU reset signal OK or not. If not, it means CPU is broken. Stop repair. And then, check Y1000 clock crystal OK or not. If not, replace the new one. Next, check 16 lines power of CPU OK or not. If not, check them short or not, or replace PMU. Number 3, if the current shows 50 to 80 mA, it means PMU is working, CPU is working, the NAND not working. First of all, connect the phone to PC and check the phone is in DFU mode or not by iTunes. If yes, root it. If not, take out the NAND, connect to PC and check again. And after take out the NAND, connect the phone to PC again. If iTunes detects the iPhone, replace NAND and root. If not, check USB control lines. After that, we will know the error is from CPU or NAND when root. If root fails, iTunes will show error code. Then repair according to the code. If the current shows within 50 to 80 mAh, that means CPU is working. The error is from NAND. We can try to replace the NAND. Take out the NAND and check if the phone can connect to PC. If it cannot connect it, then check USB control lines. Check it OK or not. We can replace the new NAND to confirm that if the NAND is bad. After take out the NAND, check the phone and PC connection. If yes, replace new NAND. If not, check USB control lines. If USB control lines is OK, that is CPU error. About the error code, you can take this picture, iTunes root error for reference. Number 4. If the current change as 0 to 50, 50 to 80, 80 to 50 to 0 mA, it means the error is from RAM or I2C. About this, first of all, take out the PCB and take off the cover. Check if any component is broken by water damage or fallen. If yes, then fix it. And then check 1.8 voltage of CPU I2C OK or not. If not, that means some component of this line is broken. Just replace it. And if I2C is OK, that means error is from RAM. Just replace it. If the current changes from 0 to 50 mAh or 0 to 80 mAh when turn on the phone, that might be the error from the I2C lines or up layer CPU. This is A11 Bionic CPU of Apple. There are 2 layers. Up layer is RAM. If I2C lines are OK after checked, that might be RAM broken. Just replace it. But replace RAM is very difficult. Okay, number 5. If the current is over 100 mA while power on, it means some lines in 28 lines of low voltage power of PMU is short. Just check resistance of all lines of PMU. If any one line is short, use Lesson1 to find it and fix it. This is iPhone 8 power output detection data. When you need to check the voltage or check the resistance, you can take this for reference. Okay, now I will show you some repair cases for reference. Okay, now let's check case 1. iPhone 8 boot current 0 to 750 mA cycle jump. This error case is when you take the PCB, connect to the power supply by power cable. The current shows 750 mA. Obviously, it's overcurrent. So the reason of this case is some components in PCB is short. And the solution is according to iPhone 8 1.0 version, page 16 of iPhone 8 teaching material. Measure the resistance of all the main power output to ground and check whether there is short circuit on the line. When the PP1VAS2 line is detected, the resistance value is displayed as 0 and normal. It should be free one line to judge that the line is short circuit. We use the Lesson1 to cover all the components which is connected to the line PP1VAS2 and power it with 1.8 voltage 5 ampere power supply. The capacitor C1842 was found to be damaged. According to the drawing, capacitor C1842 is a filter capacitor on the PP1VAS2 power line. This capacitor can be removed directly if it is damaged. Remove the capacitor C1842 and we measure the resistance value of PP1VAS2 line. The multimeter shows that the resistance value is 337, which indicates that the line is back to normal. The PCB is power supplied and trigger the power on. The current returns to normal and the file is repaired perfectly. Okay, let's check case number 2. iPhone 8 after triggers showing small current of 20 mA, no power on. In this case, the PCB model is PC-V0. The error is mobile phone sometimes can on, sometimes cannot. When the phone cannot power on, take PCB and connect to the power supply by power cable. The current shows 20 mA and the phone cannot power on. The case analysis is iPhone 8 and iPhone 8 Plus PCB have many cases in lines broken because of the manufacturer. The solution is we directly choke out the motherboard for hot air gun heating and then power supply again to trigger the boot. However, when the temperature of the motherboard cools down, a small current fall acutely during the stop. We judge that the board layer lines were disconnection. Generally encountered is situation. We all choose directly swap the board, but today we still try to repair it. When the mobile phone is powered on at 20 mA, it indicates that the power supply of motherboard has been working normally, but the CPU has not started to work. So we check one by one from the power supply, clock, and reset of the CPU. When detecting the clock signal, it was found that the clock signal has no 0.9 voltage when the motherboard was cooling, and 0.9 voltage when the motherboard was heating. According to the drawing, the clock signal required for the CPU operation comes from the Y1000 24 MHz clock reference crystal externally connected to the CPU. When we remove the Y1000 clock crystal to measure the pin of the pad, we found that when Y1000 pin 1 resistance is measured, the resistance of this pin changed greatly. Sometimes there are more than 700, sometimes more than 1500, sometimes more than 1900. The resistance value of the motherboard changed greatly after heating and cooling. So it is judged that this line is fouled. This signal is issued by Y1000 clock crystal and then goes to the BA27 pin of the CPU after resistor R1011. After that, remove the CPU, make a jumper from CPU BA27 pin to the capacitor C1010 pin 1, and we measure the resistance value. The multimeter displays 927, which indicates that the line is back to normal. Replace the clock crystal, the motherboard is powered supplied and trigger the power on. The file is repaired perfectly. Next case is iPhone 8 occasionally has sudden large power on current. In this case, the PCB model is PC-V0, and mobile phone sometimes on, sometimes not. When the phone cannot power on, connect the PCB to power supply, and we found that it's over current, so that caused the mobile phone cannot power on. The case analysis is iPhone 8 and iPhone 8 Plus has many cases in broken lines because of manufacture. The solution is we directly use the hot air gun to heat the motherboard and then again to trigger the boot. It was found that the phone spool cover was normal and it could be turned on, but sometimes it doesn't work. It is judged that the lines inside motherboard is not connected well. Since the current may occasionally increase, let's focus on the power of the power IC next. When measuring the voltage of all the low voltage output circuit of the main power IC, it was found that when the PP1V1S2 line voltage was detected, the voltage will jump irregularly from 1.1 voltage to 2.5 voltage, judging that this line was faulty. According to the drawing, the PP1V1S2 circuit is generated by the Buck4 buck circuit. Among them, the V11, W11, and Y11 pins is the U2700 main power IC are Buck4 LX0, and the buck inductor L2740 is installed on the line. U2700 main power supply TA pin is buck FB. There are generally two reasons for the unstable output voltage of the PP1V1S2 line. Number 1, the buck inductor is loose. Number 2, the sampling line is disconnected. Since this fault has been judged to be the motherboard line's disconnection, we directly remove the U2700 main power IC, measuring the pins of pad. When the U2700 TA pin is measured, it is found that the resistance value is displayed as OL, which show normal B211. It is judged that this pin is open line. Directly from the capacitor C2981 1 pin, make a jumper to the U2700 TA pin. Replace the U2700 main power IC, trigger to power on, and the fault is perfectly solved. Next case is iPhone8 trigger power on current 80 mA to 290 mA, which is last current. This case is overcurrent when power on. The current changed from 50 mA to 80 mA and from 80 mA to 290 mA, so that caused the overcurrent. The case analyzation are two reasons. Number 1, the low voltage lines of PMU is short. Number 2, the buck inductor of buck line in PMU is not connected well. The solution is, according to the book iPhone8 1.0 version, page 16 of iPhone8 teaching material. Measure all the resistance to ground of the low voltage output line of the main power IC and check whether the line has a short circuit. When measuring the PP 3.0 voltage Mesa S2 line, the resistance value is 0 and normally it should be 745 to judge that this line is short circuit. All the components connected to the PP 3.0V Mesa S2 line were covered with rosin and powered it with 3.0 voltage 5 ampere power supply. The capacitor C5800 was found to be damaged. According to the drawing, capacitor C5800 is the filter capacitor on the PP 3.0 voltage Mesa S2 line. This capacitor can be removed directly if it is damaged. Remove the capacitor C5800 and remeasure the resistance of this line. The multimeter displays 719, which indicates that the line is back to normal. Install it and test it. The file is solved perfectly. Okay, let's check case number 5. iPhone8 flash bar goes to 20% and showing level 40. In this case is iPhone 8 boot loop. When you root the mobile phone, the flash bar goes to 20% and showing error 40. The error analyzation is when the machine is flashing. The screen can be illuminated to indicate that the CPU has started to work, and the error that occurs on the screen progress bar before 50% or the NAND failure. So the solution is remove the original NAND, use Tracy text rec to read the boot data of the original NAND, and write to the new NAND. When writing data, be sure to perform PCIe Wi-Fi unlock. Otherwise, the Wi-Fi function may be lost after replacing the NAND. If the SN number and Wi-Fi BT address number of the mobile phone do not match the original machine, the mobile phone cannot be activated after flashing. Put the new NAND back into the motherboard and refresh the machine. The fault is solved perfectly. Okay, this is the course today. More repair cases, please check on our book, iPhone Maintenance Point and Inspire. I am Anthony. Let's meet next time. Bye.